to this edition of Silicon Grapevine. My guest today is Wally Rhines, who's spent over 50 years in the industry and has a very interesting background from sort of leading some of the top semiconductor and EDA companies in the world, some books, some inventions, and we're going to dig into a lot of the things that he's been doing over the years. Wally, hello.
Hello, Nitin.
So, Wally, tell us what you're doing right now, because, I mean, everybody knows Wally Rhines from Mentor Graphics, but probably not everybody knows what you're up to nowadays.
I'm CEO of a company called Cornami, named for a tsunami of cores, as you might guess, multi-core computing. And it was just a fortuitous intersection after I left Mentor that rejoined me with one of the entrepreneurial icons of the industry, Gordy Campbell, who had founded many companies, Chips and Technologies, 3DFX, and others. And he had put together an incredibly innovative team that had solved one of the most fundamental problems in computing, that is the ability to take advantage of parallel computing. And we put that together with some work I had done on fully homomorphic encryption and figured out that we can solve one of the most critical problems in computer security and secure data sharing. So it's been a very exciting period of time.
I think that secure data sharing was something I picked up on your keynote at the Design Automation Conference this year, 2023, in San Francisco. Tell us a little bit about what you told people there about that importance.
Well, Eric Chen of SoftBank explained to me that the whole future of capitalizing upon data as the new oil depends upon the ability to share data without ever divulging it, so that you can charge people for using your data, or more importantly, your data model that you may generate from building foundational models for generative AI, for example, and to be able to take that information, to pool it with other people's information, and then to be able to sell the use of access to that machine learning model will usher in the whole data revolution of the future.
That, I suppose, is quite significant when you're trying to do things like designing chips with AI. You need to be able to share data from other organizations, I guess, without knowing their secret sauce.
Yes, indeed. One of the things I addressed in the Design Automation Conference is the problem that a single company has only limited data for design, so they need to ally with other companies to share their data, just as banks need to get together to determine whether there is money fraud, money laundering, and to do that, they have to share their data, their confidential data, which they can only do with fully homomorphic encryption.
Wow. Okay. And how is that going? So where are we in the journey with Konami?
Very exciting. We have a whole lineup of customers who are running their benchmarks with Cornami, getting ready for our introduction of servers and other products that will make this a reality. But the secret sauce for Cornami is in the compiler technology, the software technology that was developed over a period of almost 10 years. And it's with that compiler technology plus a unique architecture to implement that technology that makes Cornami so exciting.
Okay. And so where are we going to see first sort of commercial deployment?
We haven't announced a date, but I think you can count on the next year as being a timetable that can make this possible.
Well, I'm sure EE Times will be on top of that.
I'm sure they will.
Let's talk a little bit about how you got into the industry. I mean, you started in the US Army Reserve, and then started at TI in 1972. So that's quite a good career, and you had 21 years there. Tell us a little bit about how you fell into the industry.
Well, of course, my undergraduate degree was engineering, and my graduate work was all in electronics. And I was very fortunate to be working around and for people who were in the hotbed of the Bay Area at the time. And my thesis was the first one that Craig Barrett had been involved in that involved electronics. He was a classical metallurgist. He went on to become CEO of Intel,
Hmm.
but he certainly helped me a great deal. And then I had other mentors that led the way. And Gerald Pearson, one of my advisors, actually worked on the transistor team, and he had been Morris Chang's advisor at Stanford. So when it came time to get a job, Gerald just called up Morris, and I had as many interviews as I wanted at Texas Instruments.
They've done quite a few things. I mean, in those years at TI before coming into Mentor Graphics, for that turnaround, well, yeah, well documented turnaround. You've done quite a few things, and including the invention of the first blue violet LED using magnesium duped gallium nitride. Tell us a
Yeah,
little
once
about
again,
that.
I was fortunate to be around really innovative people, and Herb Maruska and I shared an office at Stanford. And Herb was dedicated to the idea that you could develop a blue LED with a wide bandgap material like gallium nitride, but you just had to find the right acceptor levels, the right dopant.
Hmm.
And we got together and debated alternatives and fell upon magnesium. And it turns out that's what's used today in all the blue LEDs. And so we were able to patent it. We didn't profit from the patent because it really wasn't commercialized for more than 17 years, but at least we had the satisfaction of having the first patent on a magnesium doped gallium nitride blue LED.
Right, and then so how did you end up at Mentor Graphics? I think you talked about the interviews.
Well, it was a long route because I went to Texas Instruments first for 21 years out of Stanford, finishing my graduate work. And at Texas Instruments, I had a lot of different positions, but
Mm.
I had sort of topped out. My one of my bosses, Jerry Junkins, wonderful man, just told me that he thought I probably ought to move on because he was going to be CEO for another 10 years, and I was in my mid 40s, and so very really generous of him to not stand in my way, and so I couldn't go to a semiconductor
Mm.
competitor because I had a non-compete clause. So I had to go to a non-competitor, and I couldn't interview broadly because I was fairly visible as running the TI semiconductor business, and so I just had to wait for calls. And one of the calls that I had been getting for a long time was Mentor Graphics, who was actually in deep trouble at that time, and so I ended up at Mentor.
And that was what year?
That was 1993.
Oh, right. Okay. So that was really um, after the heyday of the EDA industry, because I think I was covering Mentor back in 1986 when I was covering the EDA industry. So,
Yeah, the very first wave was computer vision Calma Applicon. The second wave was Mentor Daisy Valid.
mm,
And this was toward the end of the Mentor Daisy Valid wars. Mentor had won, but Mentor got too self confident and developed a whole new generation of product. Uh, Discontinued their existing generation and then were unable to produce on the new generation. So they were in quite desperate straits at the time I took over. But I've always liked challenges. I'd rather not go into a job where the success has already been produced. I like the spirit of desperation,
a true entrepreneur or intrapreneur within a corporate environment.
I guess. Yes.
Yes. So, what are the things you had to do at Mentor when you joined? I mean, what did you think? What were the first changes you made?
Well, the first changes were keep it alive. It was draining cash at a rapid rate, gaining no new design wins because the new software didn't work, trying to keep alive some of the legacy software, and stop the bleeding. So, actually, the first thing I did was search for ways to preserve cash. We did have to reduce personnel. We had to reduce spending in a variety of areas. And then we had to look what comes beyond because it was becoming more and more apparent that this generation of software not only didn't work, it was never going to work. And so we had to look for new ways to regrow a company. And in high technology, it's very rare when a company goes in the tank and recovers.
Mm.
It's the mathematics are against it. You need the cash flow from your customers to fund the next generation. And if you're not generating that cash, then you're in real trouble.
And then, yeah, sort of that culminated in a few years ago with the Mentor being acquired by Siemens, much bigger organization. How did that all come about?
So that was 23 years later.
Yeah.
So I am always reluctant to leave something until I'm satisfied that the work has been done. And we were doing quite well, actually. And turned out, however, we were always somewhat undervalued in the market. So we always had activists coming after us or private equity wanting to take us over because there was a fairly obvious opportunity to make money. We had fought off Carl Icahn. Cadence had failed in their attempt to take over. And we had yet another activist come in, Elliott Associates, very aggressive group, Jesse Cohen. And basically, we were faced with, do we want private equity to take us over for a very small premium to current value, or do we want to look at alternatives? And I was quite fortunate. I've had a almost lifelong relationship with Sir Peter Bonfield. We worked together at Texas Instruments, and he was chairman of the board of NXP. And Joe Kaeser, the CEO of Siemens, was on the board with Peter. And he had asked Peter about opportunities for Siemens to get into electronic design. And Peter had recommended he talk to me. And that started a discussion that continued for some time. As Elliott became more aggressive, we brought in others to make sure that the Siemens offer was the highest. And as it turned out, it was. So we proceeded with that transaction for $4.5 billion, substantially more than what it was when I came. But still, it was not something I would have hoped for, but it preserved all the jobs at Mentor. Had we been acquired by someone like Cadence, the jobs would have been eliminated. It preserved our business, left some freedom to grow the business, opportunity, deep pockets for the company. Siemens really looked like the best company to take care of what had been built up at Mentor.
And I'm not asking you to sort of make a perspective, or you might want to, but it really opened up a larger market for Mentor within the industrial and the wider manufacturing arenas, didn't it?
Yes. Well, one of the things that was unusual about Mentor, unlike Cadence and Synopsys, was half our revenue came from systems companies, and we had a large range of system-oriented products, much beyond printed circuit board, thermal analysis and signal integrity, and things that were sold primarily to the big systems companies. And of course, Siemens had a tremendous momentum within that space. So for close to half of Mentor's revenue, it became immediately synergistic and accretive. The IC design was something that Siemens didn't have, and they wisely chose to keep it separate and alone and to allow it to take its own direction.
So beyond that, so you had a period as chairman emeritus, and then you moved on. You've done lots of other things through your career. So tell us a little about things, including like books you've written. Seen two. One is From Wild West to Modern Life, which is like a collection of stories, which you wrote on various plane journeys, if I remember. And
Yes.
The other one was on activists or share activists or something.
Yes. Well, when Siemens acquired Mentor, they asked me to stay on as CEO for a while and then later as CEO emeritus. Wonderful job. You talk to customers, you give speeches, but not much else. And then COVID struck and I couldn't travel. So I wrote two books. And the first one were things Daniel Nenny actually convinced me to do. because he felt that the Bay Area had been well represented in books, but most people didn't know what went on at Texas Instruments and in the other parts of the U.S. And so it helped document a lot of the history of the semiconductor industry in places other than the Bay Area. And then the second one was a collection of speeches that I have given over the years that were oriented toward a quantitative analysis of trends in the semiconductor industry and a variety of observations that are not well known, but it's a great opportunity for that kind of thing because the semiconductor industry is one that has been ruled primarily by free economics. That is, the industry grew before there were trade barriers and regulations and other things that would distort the free economic picture. And so it's a very predictable industry. The cost per transistor, for example, comes down a perfect learning curve and always has. And so you can use things like that to forecast the future and to analyze the present.
Okay, and the other one on the share activists. I think or was that a collection of essays?
Yeah, well, within my first book, I did talk some about how the activists came after me. Actually, three of the most famous activists in the industry, Carl Icahn, Jesse Cohen of Elliott Associates, and then through another board I was on, Triquent, Jeff Smith of Starboard, gave me the opportunity to interact with all of them. And they are uniquely different.
Okay.
Carl, it really is a unique personality, but his focus is all trying to make a transaction happen. And when Cadence failed in taking over Mentor, he decided it was because Wally wants to keep his job, and he didn't realize that we negotiated openly. But at any rate, he came after us and bought 15% of the stock, made a tremendous profit. He bought it at $8 and he sold close to 20. So, but in the course of that, we had to do a proxy fight, which is not something you want to do because the company almost always loses, and we lost. And he got three directors on the board, so that was somewhat of a diversion for a year or so until we could have another election, and two of those directors were not reelected. So I've been through the full score of initiation in big companies, and now, having done a startup the last 4 years, I've been through the other side.
Yeah.
In fact, the big companies I worked for always had enough money to pay their employees and their suppliers. That's not always true with a startup. And so you start a week wondering how you're going to raise enough money to pay people at the end of the week. That's a very scary feeling.
Interesting. Yeah. Tell us a little bit about you. Did you always wanted to do electronics when you were a child, or was there something else and then you fell into it?
Actually, I was much more financially oriented. I was buying stocks at a very young age and bonds, and I was starting making money in side businesses, paper routes, all sorts of things. I sold Cokes at football games. And so I was much more a business entrepreneur. I liked science and engineering. I was very good at math. So those were obvious ones, but not that obvious. I think had I not had a father who was an engineer and who was somewhat persuasive about engineering being a great foundation for whatever you do in life, I might not have pursued it.
And so what kind of engineer was he? What did he do?
He was a chemical engineer who later became a metallurgical engineer. So it was pretty easy for me at University of Michigan. Chemical engineering, materials, all were together. So that's where I ended up. And then as I went to Stanford, I went to the Department of Material Science and Engineering, which is actually a very good place to be because regardless of what area of engineering prospers, they will all need new materials. In fact, at the time I became head of TI's semiconductor business, the heads of the two other largest ones, Intel and Motorola, all had PhDs in material science and engineering. Craig Barrett, Tommy George, myself. So it actually turns out to be a very small percentage of the graduates, but a very large percentage of the CEOs.
Interesting. I mean, you had two major roles. One. I mean, well, not several roles at TI, and then with Mentor. What do you feel were your sort of greatest achievements? I mean, you're very well known as a speaker in the EDA industry just because of what you've done, and I see you everywhere. But yeah, what do you think are your achievements? Yeah, from TI and then Mentor.
So if I had to choose one, I have to say the single chip DSP, the original TMS 320 at TI, because they had such a big impact on the industry, the world, and the company. It and its derivatives ultimately became half of TI's revenue in an area where there was no hope. I took over the microprocessor business at TI in 1978, the same year that Intel introduced the 8086 and Motorola the 68000, Zilog the Z8000, and TI just about gave up hope, so no one actually wanted the job. So it was easy for a 29-year-old to be appointed head of what should have been a major division of the company. And by that time, the management had decided this is pretty hopeless. So they let us do pretty much whatever we wanted. We decided that the game in general purpose host microprocessors was already lost. And so we looked ahead. We said, if general purpose host microprocessors are the big thing today, then maybe special purpose microprocessors will be in the future. So we designed 4 chips, the TMS 320 for communications, the 340 for graphics, 360 for mass storage, and the 380 for local area networks. But the single chip DSP so overwhelmed the others that people don't even remember we did 4. And we actually were going sort of blind. We had some very distinct applications we thought would be important: speech processing, speech synthesis. And it turned out that almost none of them turned out to be important except for modems. It was important for modems. But the things that became important were things where a total discontinuity occurred. Our customers discovered the capability of digital signal processing, and they created the markets for us. Closed loop servo control for disk drives, which had all been analog before. Baseband cellular, which was all analog before, and TI actually got 55% market share in baseband cellular before they got out and Qualcomm took over. Those markets, even with the floating point DSP, high resolution graphics, all of those were things that we didn't anticipate, but we let our customers innovate. And that's what I find so exciting about Cornami. We're in the same situation. We're going to introduce a major discontinuity in capability, and I'm confident that our customers will come up with applications that we've never thought of, even though I think that fully homomorphic encryption is going to be revolutionary. There will be lots more.
Well, I'm sure we'll hear a lot more about FHE, as it's called, because it's something that's not well known in the industry still.
Yes. Well, in fact, now it's getting better known because Amazon has announced they will provide it to their customers, but a very limited form, very low speed. And but still, they're pointing out for generative AI, if you want to keep your fine-tuning proprietary information private, the only way to be sure of doing that is with fully homomorphic encryption. And with that, you can also market it, sell it to other people. More recently, today, Intel made an announcement that they are working on fully homomorphic software and eventually chip design as well to do fully homomorphic encryption because they see it as so critical. So we were out on a limb by ourselves a while ago, not so much anymore. There will be others.
So I asked you about TI and your highlights. What about at Mentor?
Well, at Mentor, a lot of exciting things happen, but the ones that were most revolutionary, there were 2. One is a few months after I came there, Mentor had an agreement with TI for second source or OEMing the TI physical verification tool. Mentor called it Checkmate. And that agreement was coming to an end, and they wanted me to go negotiate an extension. And TI really didn't want to continue working on it. They hadn't done much. Mentor had done most of the maintenance. And so they said, for a fixed price, which we paid in software, we'll just disengage and certify that there's no conflict and you can go develop your own tool, which we did. Tremendously innovative guy, Lawrence Grodd, and several others had been supporting the TI tool for quite some time, and they developed a new one, and it was called Caliber. The original intent was that Excalibur would be the extraction tool, but that didn't work out so well. But anyway, that became, like the DSP at TI, that became a very large share of Mentor's total revenue, and it changed the day. But it took a long time. But over time, that became the most revolutionary part of what I was involved in at Mentor.
Excellent. Two things I think you're probably known for. Well, one thing you're known for, which is the EDA industry. What do you see as we've seen this year and last year a whole sort of raft of announcements around AI and EDA, and it's always been there, but I think now we're sort of using it more constructively. Where do you think it will lead? I think there was one presentation from somebody about chips making chips. I think it might be an art, but where do you see that going with EDA?
Well, chips helping to make chips, I think, has been true for a long time, and they will help even more. But I don't think we'll send the chips off to do our next design. But there are many things that will evolve, and part of it is as chip design has become more complex, we had to have design automation, or we couldn't handle the complexity any other way. So some of the adoption of things that I would call analytic AI have been necessary. And if you look at the tool set across the industry, almost every type of tool has been impacted, and it's greatly improved capabilities, its insight, its ability to search out more solutions than you ever could before and find a more optimum solution. And that's where it's been really focused in the last 5 years or so. But the next stage is, in fact, moving toward the same thing we saw with generative AI, building foundation models that can provide guidance as a co-pilot for the designer of a chip. And one of the things I pointed out in the Design Automation Conference speech was you can't just load every successful design into your foundation base, because that's not what you want. You don't want completed designs. What you want are design journeys. I come to this problem, what are the alternatives and which ones have been most successful in the past, and what should I look for? Those kinds of things. And unfortunately, many companies only archive a portion of their failed path to successful design. So now I think they'll become much more cognizant of the value of both success and failure in the journey to a complete design.
That's the same in the entrepreneur journey. You need to remember the failures as well.
I guess that's true. But while I don't think you'll simply punch in a specification and a chip will come out, I think you will be able to put in a specification and start looking at alternatives as you evolve a design. There'll be more and more complex intellectual property you can incorporate in that design. And so the amount of drudgery associated with the things that frequently come back to haunt you in hookups and failure to simulate every part of a design or emulate it, some of those will be eliminated. And I think we'll be less error prone. We'll be more likely to hit specifications that are exactly on target for power and EMI and performance and other things. And so I think it will offset the fact that multi-billion transistor designs are no longer a thing of the past, and the complexity will grow, but even more so, the ability to integrate multi-die designs in a single package or in a single system we'll take on the challenge of simulating or emulating those systems. And that's something where we have a long way to go. It's you talk to people who design complex systems made up of many, many chips. The simulation and emulation technology is still very primitive.
Okay, let's turn to what what excites you, what you're passionate about uh, in the past, now, and what excites you about the future.
Well, in the past, it's always been that the semiconductor industry is one where if you didn't like what you were doing now, just wait a year or two and it'll be totally different. You're trained to do one thing in graduate school, and by the time you're 10 years into the industry, everything you're working on has been invented since the time you graduated. And so to me, it's the excitement of change. And every time people declare that Moore's Law is over and the change is no longer occurring, I look to my learning curve and say, we still have to reduce the cost per transistor every year. And if we have to do it by doing multi-layer die stacking instead of shrinking feature sizes, that's okay. We just know we have to do it. So it's one where we have our roadmap out in front of us, but we haven't yet invented the ways to get there. So we need the most innovative people in the world. And that brings me to really the most exciting thing about semiconductors and the electronics industry is that's where a large share of the really smart, innovative people have been. And that's what makes work exciting. That's what makes a career worthwhile.
And beyond work, I mean, what do you like to do when you have your spare time or your vacations?
Well, I actually don't take a vacation from Cornami or from my boards. Fortunately, thanks to the miracle of Zoom and other remote work, I can do it whenever. But I do other things. So I spend time on investments, both my own and on committees for other people. I like to analyze new companies. I like to find out what people are doing. So I keep up my contacts. I reconnect with people to see what new things they're into.
Excellent. And what would you tell a young Wally, knowing what you do now? What kind of advice would you give him or to other people who want to be like you?
Well, several things. One is pay attention to the people you're around, the people you work for, the people you work around, and the people who work for you. Ideally, if you can hire people who are always better than you are, at least at something, maybe at everything, then it'll push you forward and improve your performance. And a lot of people are intimidated by people who appear to be smarter than they are. I've been fortunate. Almost all the people who worked for me were better than I was, so they could keep pushing me up in the ranks because there was never any worry about replacing me. And the other thing about those people, I was very fortunate to have really wonderful mentors. I mentioned people like Gerald Pearson, Craig Barrett, but Morris Chang was for a brief period my boss at TI and arranged my job, and I had a terrific boss, Don Brooks, who was really he was the second president of TSMC, but really a tremendously innovative person. So I was able to work around a lot, and going to TI was good for me because they had people who were very experienced. It was the largest semiconductor company, and so I was able to learn a lot. So people I'd rate as number one. And then number two, don't be afraid to take on challenges that look like they have a high probability of failure. Because no one is going to remember what you did if you took over a successful business and made it more successful. What you are going to remember and what others will remember is the business or the technology that you pursued that everyone else thought was impossible. Those are the ones that are really fun when you find the breakthroughs.
Well, I think I would see another book from you because you've got so many luminaries who you've been having as mentors. You know, my mentors or something like that.
It could be. I've been fortunate, so there are quite a few I could write about, and they are some unique personalities, and I think I actually know things about them that are not generally known. Maybe they should remain unknown, but in some cases. But anyway, that would be a good one to think about. Daniel Nenny keeps pushing me on these things and suggesting that I do another one. We'll see. Maybe so.
Well, let's look out for that. Wally Rhines, thank you very much.
Thank you, Nitin. It's been a pleasure.